Okay guys, let's now make some comparison how ASD and LRFD um, works. Okay, how does one compare to the other is actually uh, dependent on how you look into things. But of course, when we're talking of a specific uh, a reference in structural engineering, our concern is mainly on the design of a member that could resist perhaps a certain load uh, and provide an energy, okay, an energy dissipating uh, property in its cheapest form, in its most economical makeup, or else we defeat the purpose of having a strong, efficient, and economical structure. Okay, of course, we have to place also there the practicality, the issue on methodology, the issue on beauty or aesthetic, but we have to to cut those variables into the most significant, the most important of them all, which is safety and economy. So let's try to do it on the basis of a tension member subjected to a load combination, which is widely used by so many codes, the 1.2 dead plus 1.6 live as provided for in the ASC guideline. So we determine which methodology is better in terms of economy and safety. And of course, we do it for dead and live only because this is the simplest way we can compare. But you can actually do it with the inclusion of earthquake and wind as your forces of concern. So considering the minimum requirement for safety now, we take note that in LRFD, AISC, we use this load combination. Okay, and this combination is actually guided by the expression or the equation in this form. Okay, phi here, phi Rn is equal to the summation of gamma I qi. The gamma i's are 1.2 and 1.6, and the qi's are the dead and the live. Okay, the value of the dead and the live. Of course, the i's there are simply the two load types, which is the dead load and the live load. Okay, so if we set an iteration on I equals 1 to 2, your 1 will be the dead and your 2 will be the live. Okay, so that's how to put things into order. Okay, for the ASD criteria, our simple equation is simply the resistance is equal to a factor of safety multiplied by the load, or simply the required strength. Okay, so Rn now becomes uh, uh, divided by the factor of safety becomes now your load combinations, or the load imposed on the beam switch, or sorry, on the member, which is the dead and the live. So this is the ASD criteria. So how do we make it more uh, simple to compare? So we simply divide the first equation by 0.90, because 0.90 is the as mentioned in our previous lecture, this is the reduction factor used for tension members. Okay, so this is the factor for tension members. So you can avail these factors on the AISC code guidelines. So if we divide this by 0.90, your equation now becomes 1.2 over 0.90 and 1.6 over 0.90. And if you want to make it simpler, we, instead of having a dead and live there, we divide it by the dead load. So we can remove what? Not remove, but we can put the arguments, the dead and the live load arguments, into one single argument, which is the live-dead ratio. Okay, so that's how it works a while ago on probability. And for your Rn in the ASD criteria, we simply multiply omega, which is the factor of safety. This is now your 1.67 is your factor of safety for ASD on tension members. Okay. Again, you just look at the ASD AISC criteria for such values in case you don't know what to use. Okay, so this is divided by D also, so that's why the D there vanishes, and you have now a single argument in terms of the live-dead ratio. So we divide LRFD and ASD in order for us to compare LRFD. So we come up with this equation here. So this is 0.8 plus 1.07 L over D becomes 1 plus L over D if we divide this by 1.67. Okay, so parang dinivide lang ito uli ng 1. Okay, so this will cancel out and you have this one here. Okay, so define the function. So how did I do it? I do it in Mathcad, but you can do this manually by simply substituting. We simply substitute values of L over D and solve for LRFD in terms of ASD. Okay, so what's the ratio? Okay, so but instead of doing it manually, I did it in terms of a Mathcad procedure. So I define a function ratio L over D is equal to L underscore D, and I also define a comparison ratio of LRFD underscore ASD equal to LRFD over ASD. Okay, so these are just variables, or what you call arguments. Okay, arguments are simply point of discussion. There are variables of concern. It's just used to practically to make your explanation a little bit much more classical, no? So instead of using the word variable, so it's purely mathematics in nature. So we use it in the basis of engineering terms. You call it arguments. Okay. So define range of values of L over D, and let's say I iterate from 0 to 10. You can do it manually by iterating on larger intervals. Okay, so pero pag the computer, you can use an interval which is smaller, as small as 0.01. You call this now an interval. Okay, so we now plot the function. This is now a function of L over D ratio. So this is a Mathcad solution class. If you want to do it in Excel, you can do it, or you can do it also in Mathcad. Okay, or sanay na kayo sa pagko-compute using computers. Okay, so this is now the plot. You do the Mathcad, the plotting app. Okay, so you can plot it now, and take note that the L over D ratio at a certain value of 3 gives you a unity. So what is this one here all about? Okay, so this is this one, or this axis actually, this axis here actually is the ratio, no, of the comparison for LRFD all over ASD. Okay, so it was written here in the legend, but actually this is the axis that we are referring to. And if the value is 1, it means to say that in the comparison, there is what you call equality, or so simple equivalence can actually occur at a load ratio L over D equal to 3. So that is 1. Meaning to say at load values, at load ratios equal to 3, or more or less equal to 3, then LRFD and ASD are both economical and safe uh, as compared. So yun ang ibig sabihin, ano? And then on loads less than, you get values less than 1, and load ratios greater than 3, you get values greater than 1. So what does that mean? It simply means that this is now the table now, that these values of the load ratio, which is less than 1, simply means that LRFD is better, okay, in terms of economy and safety, okay. And for this, ASD is better. But we have to stop. We don't want to stop at this point, because if we will observe the values of this ratio, we are talking here of only 5% difference from 3 to 10, and a 5% difference, and here we are talking of 20% difference from 3 to 0. So which means that